this episode of Nova Science Now.
Liftoff of Spaceship One.
Recently, NASA launched a risky rescue mission. It's all to save the Hubble telescope.
20 years ago, we didn't know how big the universe was, how old it was. Now we do. Without the Hubble, none of those things would have happened.
But how do you perform delicate repairs in a bulky spacesuit?
We're changing an electronics card out. We've never done that on orbit.
It could have sharp edges, and it could compromise the glove.
Compromise a glove is euphemism for losing the pressurization of my suit and dying.
Ultimately,
Even a tiny immovable screw could be catastrophic.
4:30.
And a sharp edge could be deadly.
These are very brave people. It's incredible. The risk of dying is 1 in 70.
Witness the mission firsthand
Code 1 is out.
and find out, did the risk pay off? And
We are headed to a site called X Swamp.
in another rescue mission here on Earth,
Like X-Files, X-Swamp?
we'll take you to the Illinois swampland,
Right here?
Right here.
where researchers are conducting a unique experiment
This is the first time that this has been done.
to find out if this harmless-looking bird is really a criminal mastermind.
A cowbird mafia exists. It's Tina Soprano instead of Tony Soprano in this case with the Cowbirds.
Also, they call him Dr. Q,
All right.
and he's always on the move.
I have exciting news for you.
He's in a rush to find a cure for brain cancer, but knows the odds are against him.
So what are the chances of me sitting here with you today when I came to this country 20 years ago?
20 years ago, he jumped this fence on the Mexican border and entered the United States as an illegal alien. Today, he's recognized as one of America's leading brain surgeons.
Alrighty, I want dance now.
And in our profile, we'll document his remarkable journey. All that and more on this episode of Nova Science Now. Hi, I'm Neil deGrasse Tyson, your host of Nova Science Now. Here's a question I get asked a lot. How many astrophysicists does it take to change a light bulb? Well, depends on the circumstances. For instance, what if the light bulb is on a priceless crystal chandelier? And you had to change the light bulb wearing boxing gloves? And what if the chandelier is way up high? And you have to stand on the top of a tall, rickety ladder to reach it. What if this intricate job must be performed in space? These are just the sorts of challenges, all together at once, facing astronauts on an important and risky mission. A team of specialists prepares for emergency surgery, a risky procedure that will cost millions. Luckily, this patient is a celebrity with an excellent health plan, courtesy of the U.S. government. The Hubble Space Telescope. The Hubble is probably the best-known scientific instrument ever. Since 1990, it's brought us unprecedented views of the universe and revolutionized astrophysics.
20 years ago, before the Hubble flew, we didn't know how big the universe was, how old it was. Now we do. We didn't know that black holes really existed. We now know that black holes are everywhere. The Hubble telescope was the first telescope to actually examine the composition of a world around another star. Without the Hubble, none of those things would have happened.
But by last year, Hubble was in trouble. It was dying, and half its instruments, including the camera that took these pictures, were already dead. The only hope to save Hubble was a shuttle mission launched this past May. Launch day, Kennedy Space Center. Within an hour from now, Space Shuttle Atlantis will launch, carrying a crew of astronauts to repair and service the Hubble telescope for the last time. I'm not the only one here to witness this historic launch. There's a few thousand spectators, plus news media. This will be the most closely watched shuttle mission in years because of Hubble's unprecedented popularity. Images from the Hubble telescope brought the universe into our collective backyard. There's nothing else like it in the history of science. So it's a bit emotional for me. I have friends and colleagues on the space shuttle Atlantis. So good luck, Atlantis. Godspeed.
7, 6, 2, 1. Liftoff of Space Shuttle Atlantis. Join the visitor against the vision of Hubble, the deepest treasure of our universe.
The climb to orbit takes just over 8 minutes.
Atlantis on its way. Vehicle rolling to heads up now to get a good communication.
Once there, it will take them 2 days to catch up to Hubble. Then, the real work can begin.
We're in the middeck of Space Shuttle Atlantis. My buddy John Grunsfeld over here.
Our spacesuits are here, and we're getting ready to go outside.
So it's a busy day, and things are just going to keep getting busier.
It starts with grabbing hold of the telescope.
Megan MacArthur now repositioning the shuttle's robotic arm to align with the telescope.
Houston, Atlantis. Hubble has arrived on board Atlantis.
If you look out there, there's a telescope waiting for us to start working on it.
The work will start tomorrow. 5 spacewalks, 1 per day. But the preparation began long ago. These 5 days have been years in the making. It all starts in 2006, when 2 teams of astronaut spacewalkers are assigned to the job. John Grunsfeld leads one team. He's been to Hubble twice before.
The Hubble was designed to be serviced by people, to take things out, put things in, turn bolts, keep it running.
John's partner is Drew Feustel. This will be his first flight.
We kind of operate on a buddy system. One person does the work, another person's handing off tools, providing support.
On the second team is Mike Good, also making his first flight.
Hubble's done some great things, and it's great to know that I'm going to get to go up and have a chance to get up there and touch it, open the doors, get inside of it to work on it.
Leading the second team is veteran spacewalker Mike Massimino. He worked with John Grunsfeld on Hubble in 2002.
Third roller.
If we can fix Hubble with its new capabilities, it's going to make some great discoveries.
There's lots to do. Replace batteries, install a brand new camera, swap out gyros, remove old optics, install a new spectrograph, and more.
Generally what we do is we come up with a whole replacement for an instrument or for a piece of equipment. And even if something little is wrong with it, you don't mess with it usually. You just pull it out, put the whole new one in.
That's exactly what Drew Feustel and John Grunsfeld are about to do on spacewalk number 1.
Ready, John. Let's go do this. Oh, this is fantastic.
Pull out the old wide field camera and put in a new one. They'll loosen one bolt, remove the old camera, insert the new camera, and retighten the bolt. One of the simplest jobs on the entire mission. But early on, there's a big problem.
Math, I put in 3 attempts and see no motion electrical. Copy.
When Drew Feustel tries to loosen the bolt holding in the old camera, it refuses to budge.
No turning. Try it without a MTL at all.
Mass, we copy that. In that case, we're with removing the MTL.
The MTL is a multi-torque limiter, a safety feature. It limits the force on the bolt to keep it from breaking. With no MTL, there's a chance Drew could break the bolt, putting Hubble in danger.
How far can we go with this, and what are the implications if I break the bolt? If it breaks, then wide field stays in.
What John said is correct.
Thanks.
If the bolt breaks, the old wide field camera is stuck in Hubble forever. The replacement, a brand new $130 million camera, which took more than 10 years to build, will come back to Earth, never to be used.
Okay, here we go. returned. Yep.
We copied and saw that. That's great news.
Well, it's been in there for 16 years, Drew. It didn't want to come out. I guess it just decided to be a recalcitrant teenager.
And the Wide Field Planetary Camera 2 is clear of the structure of the telescope.
Hooray! That's awesome news, Dad.
In the end, John and Drew finished everything Spacewalk number 1 was supposed to get done. But it was a close call that could have permanently crippled the telescope. The next day, spacewalkers Mike Massimino and Mike Good also have problems.
Crew members are an hour and a half behind the timeline at this point.
The second spacewalk ends up taking just under 8 hours, one of the longest in NASA history. The first 2 days have not gone well, and the hardest spacewalks are yet to come. Tomorrow, John and Drew will try to fix a broken instrument that can't be replaced, the Advanced Camera for Surveys, or ACS, which died in 2007. It's a new kind of work no one has ever done before, actual repairs in space.
Instead of just replacing components, we're actually going inside. It's more like neurosurgery.
To learn how they'll try to do these repairs, months before launch, I went to the Goddard Space Flight Center in Maryland. Deputy Program Manager Mike Weiss took me through the world's largest clean room. Every tool, part, and new instrument going to Hubble is kept here. In the heart of this super clean operating room is a life-size mock-up of the patient, the part of Hubble containing the instruments. Deep inside is the ACS, the vital organ that failed. It might look like a refrigerator, but this big black box is actually a precision digital camera. Just like any digital camera, ACS runs off electronics. And that's what died, the power supply.
Replacing those two instruments.
To fix it, 32 tiny screws would have to be removed, then a cover, then circuit boards would have to come out.
Okay, so this would be the offending power supply board.
Right.
Even though right now it's just a smooth surface. I would see printed circuitry here and
absolutely
components.
And they're going to pull all 4 of these boards out.
So this seems easy enough. Where's the challenge?
The challenge is it was never designed to be pulled out like that with an astronaut wearing a glove, and it could compromise the glove. It could have sharp edges.
Compromise a glove is euphemism for me losing the pressurization of my suit and dying.
Ultimately,
danger is just one challenge. Working while weightless is quite another. Things like tools and loose screws will float. And if you're not strapped down, when you try to turn a screw, your body turns instead. And ultimately, if just one of those 32 screws that has to be removed to fix the ACS should float into Hubble, it could trash the telescope forever. So how can they remove those screws safely? With a special contraption designed just for this mission, the fastener capture plate.
Which is basically a panel that is made out of a clear plastic, has holes in it that you can put a screwdriver through.
But small enough so that nothing will come out.
And as a result, we can remove all those screws, they'll float around, but we won't lose any, and then we can take the cover plate off.
To get a feel for what it's like using the fastener capture plate, I decided to try it myself.
You then need to turn 3 levers.
For 3 different screws.
1, 2, and 3 different locations.
There we go.
In space, 32 screws have to come out. I figured I'd try 2.
So I got my miner's light into number 17. Steady. There we go. I am in. We are succeeding, I think. I am not succeeding. And I can't imagine doing this in a spacesuit.
But doing it in a spacesuit is precisely what John Grunsfeld is facing on spacewalk number 3.
The fastener capture plate will be next.
The fastener capture plate now removed, having done its job.
But as the repair gets underway,
the 32 tiny screws,
the one thing that nobody expects
secured,
is what actually happens. Perfection.
Card 1 is out. Nice. I heard that.
No loose screws, no cut gloves.
Oh, that's unbelievable.
The ACS repair, probably the toughest job in the whole mission,
goes without a single hitch. Down on the ground, the Goddard engineers who designed the tools and planned the repair are thrilled.
That's a good one today. No issues, ahead of the timeline, went smooth, just like they practiced.
Over the next 2 days, the final spacewalks complete every task assigned to the mission.
The final spacewalk to service the Hubble Space Telescope is complete.
This mission hasn't just fixed Hubble, it's set a new precedent for the level of intricate repair work that's possible on spacewalks.
They've pulled out boards, replaced boards, struggled with, handles that wouldn't come off and improvised. I mean, I think we have raised the bar enormously because suddenly you can see what humans can do in space.
We're stalling minus 0.05 at
The day after the final spacewalk, Hubble is released back into its own orbit.
Flight controllers off.
It's the last time humans will ever touch or see this magnificent science instrument.
What were you thinking when you patted Hubble goodbye?
Happy voyages. I hope everything that we did worked.
Over the next few months, the new instruments get acclimated to the conditions of space. And I can't wait to see what a rejuvenated Hubble can do.
It's probably between 50 and 100 times more powerful than it was when we first launched the Hubble. So it's a completely new telescope.
Just weeks ago, Hubble transmitted the first post-repair images. It's the start of a new era in Hubble history. And later this fall, you can see those images and watch the story of the whole mission on NOVA.
You know, things can get tough out there in the animal kingdom. Disagreements between species may arise. Unpleasantries may occur. Sometimes steps must be taken to ensure the survival of the family. But our expectations have been exceeded by one particular animal who enforces its will in a manner heretofore seen only in humans. Correspondent Annalise Strachan has ventured into the swamps to track down a creature that may be giving its neighbors an offer they can't refuse.
It may look peaceful, but these quiet cow fields might be a cover for a mob. You know the type from TV.
I'm gonna make him an offer he can't refuse.
Except this time, the goons aren't human. Jeff Hoover's on the case. And we're on the trail of one of the most sophisticated crime schemes in the animal world.
Say hello to my little friend.
The suspect? The brown-headed cowbird. If you've ever seen a cow, you've probably seen a cowbird. The males are black with brown heads, and the females are sort of drab gray. Until now, intelligence was never considered a trait because of a certain reputation.
People describe them as lazy. In general, people hate cowbirds.
Why? Because cowbirds are freeloaders. They never make nests or raise their own kids. They just ditch their eggs in other birds' nests and let someone else do all the work. Just ask any bird watcher.
The cowbird chicks are totally dominate the nest scene at the expense of the chicks that are supposed to be there.
You know, it's kind of sad to see a huge cowbird and you see this tiny little songbird just running back and forth all day long trying to feed it, and the other chicks starve to death.
In fact, cowbirds are so good at what they do, they appear to be driving several songbird species to extinction. But things weren't always this way. It's partly our fault, and it all started in the Wild West. Cowbirds used to roam with the buffalo and only sneak eggs on species living close to open land. But now, with the bison gone and more man-made open land than ever before, We've invited cowbirds into every last corner of the country, pushing dozens of already troubled species to the brink.
It's a pretty serious problem. Without cowbird control, some of those populations, perhaps some of those species, would be extinct now.
And it gets worse. Cowbirds can somehow sucker over 150 different bird species to raise their offspring. How do they get away with this? Why don't the victims just throw those eggs out? That's where Jeff Hoover comes in. He's a bird ecologist with the Illinois Natural History Survey, and he thinks something in the story just doesn't add up.
There she goes. She just flew out. For the longest time, it's been thought that cowbirds are either dumb or lazy. And they figured, oh, well, all they do is they come and they lay their egg, and then they forget about it.
They just ditch it.
They just ditch it, and they never follow up.
Case closed. That is, until Hoover started studying one of the cowbird's local hosts, the prothonotary warbler.
We started seeing some really odd things happening. I would be watching a pair of warblers bringing food to a nest, and that nest contained a cowbird baby, and I'd happen to notice, oh, is that a female cowbird? Yeah, there's a female cowbird sitting maybe 50 feet away, kind of hidden, and watching. And then I just kind of wrote that off, but then I saw it again.
Then Hoover stumbled on a surprising twist. It happened when he started removing cowbird eggs from warbler nests in an effort to increase the number of warbler offspring.
And when we started doing that, we found that some of these nests were starting to have things happen to them. We'd see warbler eggs disappear, warbler eggs get broken. The usual suspects would be a raccoon, snakes, flying squirrels, but they weren't a problem before we started removing cowbird eggs.
Trashing nests? Are we talking about revenge?
We're in a little bit of denial because we didn't think that the cowbirds would be capable of this kind of sophisticated behavior. No one had really documented it before, and cowbirds have been studied a lot.
We are talking about cowbirds here, aka lazy bums who pal around with cattle all day. Could cowbirds really be doing this? To find out, Hoover would need a scheme to catch these culprits red-handed, and he knows just the place to start. Welcome to Illinois swamp country, where cowbirds get away with dumping over 4,000 eggs on warbler parents every year.
So where are we headed?
We are headed to a site called X-Swamp.
Like X-Files X-Swamp?
Like X-Files. There aren't any aliens here, but it's got about 20 pairs of the warblers that we're studying, and there's also cowbirds here, so it fit the bill for what we needed.
The game plan. First, stake out nesting sites across warbler territory.
And maybe if I can take the pose from you. And this looks like a really good spot to put up one of our nest boxes.
Right here?
Right here. There. Okay. So we've got our two poles.
Next, we'll line up hundreds of carbon copy nest boxes all over the swamp.
So now we've got a nice little home here for the warbler.
Right. And if we left it out like this, they probably wouldn't use it. So we need to make
it looks a little suspicious, I have to say.
Yeah. We need to make it blend in a little bit better with the environment out here.
But how do you keep other critters like snakes and raccoons from butting in?
So what's that?
So this is axle grease. It keeps things like raccoons from being able to climb up and do anything with the nest.
This is like predator proofing.
Exactly. This is really important for us to be able to eliminate yet another one of the possible suspects for who's ransacking our warbler nests.
So we've set the scene and ruled out the usual suspects. But to pin any nest trashing on the cowbird, we'll need to rule out the warblers too. They could be trashing their own nests for all we know. And that calls for a little custom modification to the housing.
Oh, look at that.
There we go.
Perfect.
Yeah. So this is the wide opening, or the big opening, that both the warblers and the cowbirds can fit through.
Okay.
What we're going to do next is we're going to take this smaller drill bit, and the warblers, believe it or not, can still fit through that size of an opening.
It's tiny.
But female cowbirds are about 3 times the size of the warbler. They can't. Now we've got a cowbird-free nest box.
Nice. It's convertible.
Exactly. So we start with the large opening because we want the cowbirds to come in and lay their eggs in the nests. And then we will remove cowbird eggs and put this insert in. And if we put this insert in there, these nests should all be safe, because cowbirds can't come in.
The plan? First start all the boxes with big openings. That way cowbirds can get in and lay their eggs.
Once the female warbler leaves, then it's go time for the female cowbird. The cowbird comes stealthily, flies in, lays her egg in about 10 seconds time, and blasts off, and she's done.
Then take the cowbird eggs out, and for half the boxes, put those inserts in. Now these nests should all be safe. The others still have big openings, so if they're the only ones to get ransacked, we'll know who done it. Leaving one last step, waiting.
Head out this way.
All right. So, do you ever make a cowbird egg omelet?
My guess is that it probably wouldn't taste too bad, especially with a little bit of Tabasco sauce on it.
The stakeout begins. Dozens of nests, day after day. The team slogs through the muck to check the status of the eggs. It takes months, but slowly a pattern begins to emerge. Only the nests with big openings are getting ransacked.
And over a number of years, the patterns became really, really clear to us. That, oh my goodness, we've actually got experimental evidence that female cowbirds are really doing this stuff.
Sure enough, those small-holed nests cowbirds couldn't fit into were 100% safe. It's the most compelling experimental evidence ever of an animal besides us exacting a mafia-like retaliation.
My first reaction was, oh boy, they're way smarter than we thought.
And they even caught the whole thing on tape. With quick, sharp stabs, the female cowbird does the dirty deed. Within seconds, the entire warbler brood is destroyed.
We had really nailed it. But then, well, why would they destroy the contents of the nest? What does that do for the cowbird?
Perhaps it's a power play cowbirds use to force other species into accepting their offspring.
Because the warblers could learn, if you don't play along with this game, if you don't raise my offspring, there's a penalty. And that penalty is that we're going to come back and we're going to mess up your nest.
We suddenly have to view these birds as much more sophisticated than we'd ever thought. That says some amazing things about avian intelligence.
So maybe it's time to reconsider the cowbird's reputation.
I think the word debunked is exactly what we've done. They come back and they monitor nests. They're actually seeing their offspring being taken care of. What I really like about it is that it's the female cowbirds, too. It's Tina Soprano instead of Tony Soprano in this case with the cowbirds.
Nothing personal. It's just business.
Plenty of great scientists have made a mark, even though they came from humble origins. Albert Einstein, when he was younger, was a patent clerk. Dmitri Mendeleev, inventor of the periodic table of elements, was a poor kid who hitchhiked thousands of miles across Siberia just to go to college. In this episode's profile, we meet a brain researcher whose journey of discovery was rife with challenges of its own.
It's early Monday morning, and Dr. Alfredo Quiñones-Hinojosa, or Dr. Q as everyone calls him, slips into his lab coat as routinely as Mr. Rogers puts on his sweater.
All right.
His day begins with a quick sprint through his lab to check on things. And, as always, a good wash.
Clean your hands all the time. You can never clean your hands too much.
The pace here is fast, because lives hang in the balance. Lives that could be lost to a dread disease that, so far, has defied understanding.
All right. What we're trying to understand in my laboratory is very simple. It's really not that complex. We're trying to understand, how does brain cancer originate and how does it spread?
To answer those questions, Dr. Q and his research team are looking at neural stem cells, which are taken from human brain tissue. These cells have the ability to become different types of mature brain cells. Dr. Q thinks that in brain cancer, something may go wrong with these cells, causing them to grow out of control and seed tumors that are frequently malignant.
Certainly, if it is malignant brain cancer, virtually almost no possibility of cure.
If these cells are growing out of control, and if Dr. Q and his team can determine why, then maybe one day they'll be able to stop or reverse the process, transforming brain cancer from a deadly disease to a chronic but manageable condition.
We are at the forefront of understanding human tissue, human cells.
It's hard to get human brain tissue to study, especially tissue from living patients. But Dr. Q has a special connection. Turns out, he has a close relationship with one of the country's top brain surgeons here at Johns Hopkins, Dr. Alfredo Quiñones-Hinojosa.
Good morning. I have exciting news for you.
When he's not in his lab, he's with his patients.
Very, very benign meningioma. Yours was the size of a tennis ball, but the mass is all the way right here. Oh, look at you. You did cut your hair, huh? How are you?
Just fine. How are you, doctor?
You did.
Tomorrow, he'll be operating on Don to remove a brain tumor or lesion.
This is the actual MRI. You can see the lesion right here, you know, right here.
That whole U-shaped area.
The whole U-shaped area.
Well, I'd be lying to you. I didn't say I was nervous.
No, of course you are, and
but
I understand.
I know I'm in good hands.
Well, I promise you, this is what I always tell my patients. I promise you that my goal is to get you in and out safe.
On the day of surgery at the cashier's line at breakfast, he runs into Don's sister and brother-in-law, who asks him in Spanish, "Are you ready?"
Listo?
Listo.
This isn't a day for theory or larger questions. Today, as he walks into the operating room, the scientist is a surgeon. It's a transformation that can be seen in his eyes.
No doubt at that moment. Okay? There's no place for that at that moment. Because that moment, when we're about to walk into the arena, into the operating theater, there's no place for mistakes and there's no place for errors. And I tell them specifically, when we go in, it's going to be all positive energy, all that passion, all that training, everything that I have done in my life to prepare for that specific moment is going to come out. And we're going to go in together and we're going to take care of this.
Don's tumor or lesion is just millimeters from the part of Don's brain that controls his speech. Dr. Quiñones has to keep Don awake and talking to make sure they don't damage his ability to speak or make him mute for life.
Alrighty, I want Don's mouth to be a little bit moist.
To be sure, they run a test first. As Don counts, Dr. Quiñones stimulates his brain to locate those areas that determine speech.
30.
You right there, Don?
Yeah.
okay?
Yeah. 31, 32, 33, 34, 35.
You're okay.
I know in my heart that this is a tough fight.
38.
I know that the chances that I may have a significant impact on this disease are not very good. As a matter of fact, to be honest with you, the odds are overwhelmingly against me succeeding in this field as far as finding a cure or a better way to treat brain cancer. But so were the chances of me sitting here with you today when I came to this country 20 years ago.
Chances were about all Alfredo had in 1987, and they were slim to none. He was a Mexican citizen, poor and desperate to come to America when he jumped this fence and snuck into the country as an illegal alien.
It is tough to be poor. It is tough to be poor in the United States. Imagine how much more difficult it is to be poor in poor countries. And it's tough to survive in that environment, to be honest with you. I think that it was pretty clear to me that this is what I needed to do.
Alfredo grew up in Mexicali, just across this wall at the California border. Neither of his parents made it past the first grade. The same grade little Alfredo was in when he started managing the finances of his father's gas station.
By the age of 5, I was already working. By the age of 10, I was a major contributor.
What little the family had disappeared along with the Mexican economy in the 1980s, and Alfredo jumped the fence at 19. He became a migrant worker in the San Joaquin Valley.
At first, I was thinking, I am going to take over the world with this. I am going to go back to my country triumphant, and I am going to be making a lot of money. Then I get my first check, about $130 a week, and I realized this may take a little bit longer, and this is hard work.
He lived in this trailer for about a year, all by himself.
It was a palace.
Alone and depressed, Alfredo made it to Stockton, where he shared a room with other family members and enrolled in English classes at San Joaquin Delta Community College. There, he met Anna.
I kept seeing him walking across this little area where everybody would sit and relax, and I would see him just fly by very fast.
They became friends, but didn't date for another 2 years.
I just never, I never thought. I mean, it's my insecurities. It's how can this beautiful woman be interested in a guy who has nothing?
I saw something in him right away that he was different, and I think that's one of the reasons why I was attracted to him, because I could see the fire within him that, someday, somewhere, something fabulous was going to happen with him.
Alfredo kept moving quickly. From Berkeley, he went to Harvard Medical School. He became a U.S. citizen, married Anna, had 3 kids, a dog and a cat, did his residence and postdoc at UC San Francisco, and started his lab and became a surgeon at Johns Hopkins. 4 hours into Don's operation, Dr. Quiñones removes the tumor, leaving Don's speech intact. Don has already agreed to give Dr. Q's lab samples of his brain fluid and tissue from the tumor. And Don, his brain open and with Dr. Q's fingers literally inside of it, says,
"Take as much as you want."
Isn't that amazing? I can take his speech away just like that, just by going a millimeter over, by taking a small vessel, a microscopic vessel that you cannot even see. Anything can change radically, and yet he said, take as much as you want.
Don doesn't know that he's just given his tissue to a research team full of hungry overachievers who understand that ending their week every Friday night with a lab meeting to discuss their research until 10 p.m. is just a small price to pay for working with Dr. Q.
Jason Chang, I'm from San Francisco. I went to University of California, San Francisco Medical School. Sophomore at Johns Hopkins University.
From MIT. I'm from Oxnard, California.
Guayaquil, Ecuador. From India.
Wakefield, Rhode Island.
Dr. Q is sharing some of the amazing opportunity he's had. But he's also got a lab to run. And if he can't move fast enough to accomplish his dream, he's hoping one of these young people will get the chance.
I have to recognize that I may never be able to have a significant impact on brain cancer. So my duty is to train those future generations.
In Dr. Q's version of the American dream, rigorous, sometimes endless work leads to more and bigger dreams. Earlier that day, just 2 days after his surgery, Don went home. Living proof of Dr. Q's American dream. Living to dream some more. Most of us hold in our minds memories of our lives so vivid that when we recall them, they seem real and indelible. They're an essential part of who we are. But as we explore the mechanics of the brain, we're starting to learn exactly what these memories are made of. And it turns out, a lot of it boils down to chemistry. As correspondent Chad Cohen reports, researchers are discovering the precise molecules that can create memories, as well as the molecules that can erase them forever.
This is the brain that, more than any other in history, has allowed scientists to make sense of your brain. For 82 years, it resided in the head of a man named Henry Gustav Mollison, better known as HM. He was perhaps the most studied patient ever. And that didn't end when he died last year. With HM's permission, neuroanatomist Jacopo Anese went to work dissecting his brain into 3,000 slices.
You can imagine the brain being like a book. And our tissue slices are the pages of this book. The only catch is the slices are transparent, so you cannot really see anything until you use a lot of obscure chemical processes to reveal the features in the tissue. Eventually, the entire book would be completely stained, and it will tell us the story of this brain.
It's a story that begins with epilepsy. Epilepsy so severe that by 1953, HM had reached his breaking point.
He had to stop working because of the frequency of his seizures. It was just too dangerous. So he was basically at home with his parents. His life was on hold.
In desperation, HM let surgeon William Scoville remove slivers of brain on either side of his head, each containing a seahorse-shaped structure called a hippocampus. This might have seemed reasonable at a time when we knew almost nothing about memory. And it did quiet his seizures, though at a terrible cost.
Do you know what you did yesterday?
No, I don't.
How about this morning?
That I don't know myself. I can't tell you because I don't remember.
HM's condition might have seemed like simple dementia. But as neuroscientist Brenda Milner discovered, it was anything but.
He would say, right now it's like waking from a dream. Right now everything is clear. But what happened just before?
Milner found that HM had a normal IQ. He could crack jokes, solve puzzles, even, to some extent, remember.
So HM could remember everything that happened prior to the operation. He could remember the trauma of his childhood. He could remember going to elementary school, to high school, working in the assembly plant.
What he couldn't do was hold on to new information for more than a few minutes. In a moment of insight, Milner concluded the hippocampus must make long-term memories out of short-term ones.
That was a groundbreaking finding because it showed that the ability to establish long-term memories is localized to this tiny area in the brain.
If HM had contributed nothing more, his fame would have been assured. But he would go on inspiring discoveries for decades. The next involved a pencil, a mirror, and again, Brenda Milner.
She did this brilliant test in which she had HM draw the outlines of a star without looking at the star, but looking into a mirror.
It's hard at first to draw within the line, but could HM, like people with normal memory, learn to do it with practice? After 3 days and 10 trials, his performance was nearly perfect.
Well, he said, I thought this would be difficult, but it looks as though I've done pretty well. He had no memory of all these learning trials that he had been through and the beautiful learning. And that was the real contrast.
So, HM could remember a motor skill, but not recall a fact or an event. It was a key discovery, because it showed there were different kinds of memory dependent on different parts of the brain. But what is a memory anyway? Nerve cells communicate by sending electrical signals, which trigger the release of chemicals across tiny gaps called synapses. As one cell speaks to another, chemical changes at the synapse make it easier for the signals to pass. If only a few signals are sent, this transformation among a network of cells is temporary, resulting in a short-term memory. But if the signals keep coming, changes at the most active synapses become permanent, forming a long-term memory.
So long-term memory actually involves an anatomical change in the brain. So as I like to say, if you remember anything about this conversation tomorrow, it's because you will have a slightly different head than you had today.
But what maintains a long-term memory? How can you recall something that you may not have thought about for 20 years? Neuroscientists Todd Sachter and Andre Fenton think the answer may lie in a molecule called PKM zeta that accumulates at synapses as memories form.
PKM zeta acts as glue, if you will, for fixing the connections amongst the neurons that were active together, so that later in time those neurons are bound together and permanently bound together and can become active again to recall the experience.
To assess the molecule's importance, Fenton set up an experiment that would give the rat a memory. He placed it on a revolving table, where in one area, it would receive a mild shock.
There's the rat, and he's approaching the shock zone. He's beginning to move a little bit, but looks like he's going to enter the shock zone. He's gotten shocked, and he's just run away. He's approaching it right now.
Soon, the rat always avoided the shock zone.
And he's walking away. So when the rat stays away from a particular area, we can imagine that he has remembered where he was shocked.
Then, Fenton injects the rat's hippocampus with a chemical called ZIP, known to undo the effect of PKM zeta.
And what we observed, which was quite remarkable, was the rat acted as though it had forgotten completely where the shock zone was. And it explored the arena as if it was in the arena for the first time. Just got shocked.
Yet, the rat could learn once again to avoid the shock zone.
So we hadn't damaged the rat's brain. We hadn't broken its ability to learn anything. What we had simply done was specifically erased the memory for that shock zone.
Without PKM zeta, the rat cannot maintain a long-term memory. While this is not the only molecule active at synapses, it does appear we may have found a crucial ingredient of memory, one that explains how a 3-pound lump of flesh can store, indefinitely, vivid recollections of everything from birthdays to weddings to episodes of Nova Science Now. Meanwhile, the man who launched the modern era of brain research is making his final contribution. 3,000 glass slides of HM's brain are being posted on the internet, where researchers will be able to examine them down to the level of individual neurons. And what would HM have thought about all this?
The way I figure it is, what they find out about me helps them to help other people.
And now for some final thoughts on looking up. 400 years ago, Galileo, a mathematician in Venice, Italy, built a telescope of his own design and used it in a way that hardly anybody else at the time thought of. Instead of looking at birds or spying on neighbors, he looked up. He looked up at the sun, moon, and stars. Then and there began a 4-century legacy of discovery that would permanently transform our relationship to the universe. Over these years, we went from thinking that Earth was the object of creation, positioned at the center of all motion, to discovering that Earth is but one of many planets, that the sun is one of hundreds of billions of stars in the Milky Way galaxy, that the Milky Way galaxy is but one of 100 billion galaxies in the universe. Sounds depressing, but you know what else telescopes have shown us about our place in the universe? They've shown us that we're not somehow separate from the cosmos. We're part of it. The atoms of our bodies were forged in the fires of stars that burned billions of years ago, exploding these ingredients into space for subsequent generations of stars to use. This atomic and molecular kinship connects the sun to every other star in the galaxy. It connects Earth to every other planet in orbit around them. And it connects us to any life that may thrive there. So, as we say in my field of science, it's always best to keep looking up. And that is the cosmic perspective. And now we'd like to hear your perspective on this episode of Nova Science Now. Log on to our website and tell us what you think. You can watch any of these stories again, download additional audio and video, explore interactives, and hear from experts. If you want to get the scoop on upcoming broadcasts and find out what goes on behind the scenes, you can sign up for the weekly e-newsletter at pbs.org. That's our show. We'll see you next time.
This Nova program is available on DVD. To order, visit shoppbs.org or call us at 1-800-PLAY-PBS.